Hello, this is Ryan Woodward recording for Intel's Digital Logic course. This is Lab 3, Part 3. And in this part, we needed to build a master-slave D-latch. Here is the truth table to that and a little nice diagram. Even though it's not identical to the Intel one, it is basically the same because we're knotting the first clock input to the master latch. The expected output is Q bar will be high if D0 is clocked at low, and if D is high and clocked, then Q will be high. And the other outputs are here at last Q or the last Q bar, but that's a little more complex and I won't get into that. But here's the VHDL code. I did not do this in Verilog, and frankly, it's not difficult to bring this over to Verilog. I could probably type this up in just a minute, but I did not do it because I'm running low on time this evening. But aside this, we can see that we declare a D-latch component in our VHDL, the same inputs exactly as we can base from our diagram down here, D, clock, Q, and Q bar. And we have QM as an intermediate, and QO I just labeled as Q out. That's what that stands for that second intermediate signal here. And QM is that middle signal there. And we pass the result of the master D-latch to QM and QO. Those are the intermediate signals, and we can see that those are going into here. QM being Q bar, but QO actually is, I basically just make it the output, but I don't actually use it. As we can see, the slave D-latch receives QM but not QO, and once that's clocked, we'll see Q and Q bar go to the final output on the LEDs in the demo. And here again is the D-latch, just in case you're looking for that. This is just a basic data flow model. If process is D and clock, if clock is 1, Q is D, and Q bar is always going to be the opposite of what Q is. So regardless of what it is, it will be knotted. All right, and that's it for this portion. Here is a brief demo. Thank you. All right, and this is Lab 3, Part 3. This is a master-slave D-latch. We essentially implement two D-latches. One is called the master and one's called the slave. And we have the input D here on this switch, this far right switch, and our clock is this button here. And aside that, we should see Q and Q bar here, respectively, on LED R0 on this end here. So, as we recall from the demo, our truth table, if D is 0, then we should see Q bar go high when we clock it, and we do. And if D goes high and we clock that, we'll see Q go high, and we see that as well. And this is just why it's called the latch. Like on the clock, we have that input going to the first latch knotted, and so that allows us to get that alternating clock there. We can flip this back and forth, and this is that latching effect per se. All right, and that's it.